All right, when we left off, we were talking about the domain of sine and cosine. Now we can put in any angle we want, so the domain is essentially all real numbers. Now the range, let's take a look at the range of sine and cosine, right? The range are all the possible output values, right? So it's all the possible y values of sine and cosine. And you can see that the y values just oscillate between 1 and -1, back and forth, 1 to -1, and they never get the y values never get bigger than 1, and they never get smaller than -1. So the range of both sine and cosine is between 1 and -1. So now we can get -1 and we can get 1. So I'm going to use square brackets in my interval notation to indicate that the 1 and -1 are included. Okay, so -1 comma 1, okay, with square brackets. That's the range of the sine and the cosine functions. So how about the symmetry? Now symmetry, let's take a look at the symmetry of sine and cosine. Let's actually take a look at cosine first, because you can see that if I look at the y-axis, you can see a symmetry about the y-axis. And if I take any angle on the positive side of the axis, like say pi or pi over 2 or 3 pi over 2, the angle on the negative side of the x-axis will have the same value, right? So if I look at like pi over 4, the cosine of pi over 4 is square root 2 over 2. But also the cosine of a negative pi over 4 is also pi over 2, square root of 2 over 2. Sorry. All right. So, and you can also see it, like if I look at these negative, I can look at, like this is pi over 4, and this is a negative pi over 4. You can see that both of the x coordinates are the same. They're both going to be a positive square root 2 over 2. So there's a symmetry in the cosine function about the y-axis. So we say that cosine has even symmetry. Okay, and what that means is that the cosine of negative theta is equal to the cosine of theta, right? Okay, because we have that symmetry about the y-axis. Okay, now sine has odd symmetry. We call it odd symmetry, really, because it has the same symmetry as an odd power function, really. So if you look at an odd power function like x cubed, it has a certain symmetry, and you look at an even function like x squared or x to the fourth, it has that symmetry about the y-axis, whereas odd functions have a different symmetry. It's odd symmetry is if the sine of negative theta is equal to negative sine of theta, right? So there's this there's a little different symmetry, right? So if you look at, again, I didn't draw but down here at say this is a negative pi over 2, you can see that the sine of pi over 2 is positive 1, and the sine of a negative pi over 2 is negative 1. Okay, the same way here, if I drew pi over 4, right? The coordinates here would be a positive square root 2 over 2, but the y coordinate is negative square root 2 over 2. Okay, so we call that odd symmetry when the function at the negative value is the negative of the function of the positive value. All right, so sine of negative theta is equal to the negative sine of theta. So we call that odd symmetry. All right, so that kind of summarizes some of the key features of sine and cosine, the sine and cosine functions. And I'll meet you in the next video for more fun with sine and cosine.